Hi everyone, and welcome to this deep dive into the structure of the internet, the invisible highways and the secret phone books that make streaming, gaming, and browsing possible. Whether you're studying for exams or just curious about how the online world works, this video will break down everything from URLs to DNS, IPv6, and why your Wi-Fi sometimes acts up. So let's get started. By the end of this video, you'll be able to decode URLs like a pro and explain why we don't just use IP addresses. You'll be able to describe how DNS works. It's like the internet's GPS, guiding data to the right destination. You'll be able to compare LANs, which is your home network, and WANs, the global internet. You'll be able to understand why IPv6 is saving us from an internet address crisis. So let's get started with a real-world puzzle. Right, picture this. You're in London, searching online for Hilltop School. But there's one in New York and one down the road in Manchester. How does your computer know which one to show? Here's the secret. Your request doesn't travel alone. It's broken into data packets, like digital postcards, that zip through the internet backbone, a network of superfast fiber optic cables and satellites linking continents. But how do these packets find the right school? That's where DNS, or the domain name system, steps in. DNS acts like a multilingual translator. When you type hilltopschool.com, it converts that name into a unique IP address, like turning Buckingham Palace into SW1A1AA. Without DNS, we'd all be memorizing strings like 142.250.187.14 instead of google.com. Now that would be quite chaotic, right? Now let's zoom out a little. The internet isn't one single entity. It's a network of networks. Think of your home Wi-Fi as a tiny village road. That road connects to a bigger highway, which is your ISP, or your internet service provider, like BT or others that you may have come across. The ISP then merges into the internet backbone, the global superhighway made of undersea cables, satellites, and massive data hubs. For example, when you watch a TikTok video, the data races from TikTok's server, maybe in the United States, through the backbone to your ISP, then through your router, and finally to your phone. If the backbone is the M25, your ISP is a slip road that lets you join the traffic. But what happens if part of the highway collapses? Let's find out. Imagine a ship's anchor snaps a backbone cable between France and the USA. Does the internet crash? No. The internet is built with redundancy, multiple backup routes. Data packets simply reroute through other paths, like detouring through Asia or Africa. Think of it like your commute. If your usual train line is down, you take the bus or another tube line. The internet does this automatically, thanks to routing protocols, smart algorithms that find the quickest available path. But what if both cables to Scotland fail? Local traffic might slow down, but global data will still flow through other backbone routes. The internet is like a spider's web. Damage one thread and the rest holds strong. Every device online, your phone, laptop, even your smart fridge, needs a unique IP address to send and receive data. The old system, IP version 4 or IPv4, uses addresses like 192.168.1.1. But with only 4.3 billion combinations, we've run out. Why? Because your phone alone might use 3 IPs. One for Wi-Fi, one for mobile data, and one for Bluetooth. This is where the IP version 6 or IPv6 enters, the hero that we kind of needed. Its addresses look like this: 2001 colon 0db8 colon 85A3 colon 8A2E colon so on and so forth. So instead of 4 numbers, it uses 8 groups of hexadecimal digits, which are numbers between 0 to 9 and letters from A to F. How many addresses does that give us? Enough to assign a unique IP address, a unique IP to every atom on Earth, with trillions left over. So next time your Xbox connects online, thank IP version 6 for keeping you in the game. Now let's break down a URL. Take https://www.bbc.co.uk/news. The protocol https with the 2 forward slashes is the language your browser uses. HTTP is standard, but HTTPS adds a padlock encryption to keep your data safe. The domain www.bbc.co.uk is the website's name. The www stands for World Wide Web, but it's optional. Typing bbc.co.uk works too. The path with the /news directs you to a specific section, like chapters in a book. Now, without URLs, you'd need to type 212.58.244.70 to get to the BBC. URLs are the friendly nicknames of the internet. DNS is like a team of librarians working together. When you type amazon.co.uk, here's what happens. Your browser asks your local DNS server, like a librarian at your school. If it doesn't know, the request goes to root DNS server, the head librarian, which directs it to the .uk server, which is the British section. The .uk server then points to Amazon's own DNS server, which finally gives the IP address 176.32.103.205. The entire process takes milliseconds. Without DNS, the internet would be like a city with no street signs, everyone lost and confused. Have you ever dreamed of owning yourname.com? Here's how it works. Registries like ICANN manage domain extensions .com, .org, and ensure no two sites have the same name. Registrars such as GoDaddy and One sell domains. Prices vary. .com costs around £10 per year, or maybe a little bit more, while .tech might be quite a bit cheaper. Here's a pro tip though. Use tools like Whois to check if a domain's taken. And a fun fact, insurance.com sold for 27 million in 2020. So if you've got a pretty killer domain idea, act fast. It might be worth millions someday. Right, so a LAN or a local area network connects devices in a small area, like your home or school. A single computer on its own is actually called a standalone. When you have two computers or more connected via a network, this is usually where a local area network or a LAN starts up. So devices link via Wi-Fi or Ethernet to a router. The router is like the traffic cop of your network. And there are some benefits. Sharing resources, printing that essay from your laptop or playing Minecraft with siblings. The central security. So one firewall protects all devices connected to the network. But what if your LAN slows down? Check for too many devices, like a party where everyone tries to talk at once, or reboot your router. It's the digital equivalent of turning it off and on again. Bus topology is like a classroom where everyone shares one microphone. Only one person can speak at a time, and if the mic breaks, the whole class goes silent. It's simple but risky. Now, a star topology is like a call center. All lines connect to a central hub. If your headset dies, everyone else keeps working. It's faster, safer, and why most modern networks, including your home Wi-Fi, use this setup. Now, if you'd like to try a fun experiment, you might want to give this a go. So unplug your router, the central hub. What happens? Everything stops, right? Which will basically mean that you're using a star topology. Wi-Fi happens through a wireless access point. Imagine the wireless access point as a radio DJ broadcasting on a specific frequency like 2.4 gigahertz or 5 gigahertz. Your devices tune in to this frequency to connect. But Wi-Fi has limits. Range, walls will block signals, and you might have lost connection in the bathroom at some point. Interference, microwaves and baby monitors can jam Wi-Fi like static on a radio. But here's a tip: if you want to try and minimize some of those issues, you might want to consider placing your router centrally away from metal objects. And if your video buffers, blame Wi-Fi congestion. Too many devices on one channel can cause that congestion. Okay, so that's the end of this short video. Thanks for watching. If you found this video helped you understand the internet a little bit better, hit the like button, subscribe, and ring the bell for more tech deep dives. Before you go, how many IP addresses does your home use? My smart bulb, TV, and my phone are already hogging 3. Let me know in the comments. Stay curious, stay awesome, and keep exploring. Bye for now.